All right, let's talk about learning. You know that feeling, right? You're staring at a book, reading the same paragraph for the 10th time, and it just won't stick. It can feel like you're in a battle with your own brain. But what if I told you it doesn't have to be that way? What if there's a science to making it all click? Well, that's exactly what we're going to crack open today.
Seriously, it's a feeling we've all had. Doesn't matter if you're a student, a pro trying to pick up a new skill, or just figuring out a new hobby. That friction, it's real. It feels like your brain just has its own agenda sometimes. But here's the good news. We aren't just guessing about this stuff anymore. There is an entire field of science dedicated to understanding this exact struggle, and, more importantly, how to beat it. And here it is. It's called the science of learning. Now, this isn't about the latest education fad or some myth your teacher told you. This is the real deal. Decades of cognitive science research digging into how our brains actually learn. And the most important part, once you get these core principles, you can start working with your brain instead of constantly fighting against it.
So, where do we even begin? Well, the journey of learning anything new starts with that very first spark, that initial connection when a new idea pops into your head. So how do we make that happen? The science on this is crystal clear.
This right here, this is the bedrock of all learning. Think about it. You can't just build a house in midair, right? You need a foundation. It's the exact same with knowledge. You can't build a new idea on nothing. Every single new concept needs a hook, something you already know that it can latch onto. That's how we build a strong web of understanding, not just a random pile of facts.
And this has some really practical real-world consequences. For teachers, it means you can't just teach things in a random order. The curriculum has to be sequenced carefully, building from one idea to the next. It also means that things like analogies, they're not just cute teaching tricks. They are absolutely essential tools for mapping something new and complicated onto something the student already gets.
Okay, so we've made that first connection. Awesome. But how do we get that new idea to actually stick around? To do that, we have to understand how our memory is built and, more specifically, where its biggest bottleneck is.
So just imagine your working memory is like a tiny little workbench. You can only work on a few things at once. If you try to pile too much on top, stuff just starts falling off. It gets totally overwhelmed. Your long-term memory, on the other hand, is like a massive warehouse with basically unlimited space. The entire goal of learning, really, is to move information from that tiny cluttered workbench into the vast organized warehouse.
And this leads us to a huge idea, cognitive load theory. All this really says is that if you try to dump way too much information on someone at once, you're going to overload that little workbench, that working memory. And you know what happens then? Nothing. Nothing gets transferred to the warehouse. So good teaching is really all about managing this cognitive load. So how do we actually do that? How do we manage the load? Well, one of the most powerful evidence-backed tools we have is something called the worked example effect. Basically, instead of throwing a complex problem at a beginner and just saying, good luck, which would cause a massive cognitive overload, we can walk them through a solved problem first.
You can see how this works, right? It's a genius way of slowly handing over the reins. First, the teacher explains it and shows how it's done. Then the students try it out with a safety net. And finally, that support is gently pulled back until the student can do it all by themselves. It totally respects the limits of our working memory and builds skills without causing a meltdown. Okay, so the information has successfully made it from the workbench into the warehouse of our long-term memory. But how do we make sure it stays there? How do we make sure it becomes a skill we can actually use when we need it? The answer comes down to two things: practice and feedback.
Now, this is so important. Not all practice is the same. We have all tried massed practice, cramming, and it feels like it's working. It creates this thing researchers call an illusion of mastery, but the knowledge is super fragile. Spaced practice, though, spreading your study sessions out over time, is scientifically proven to work way better for long-term retention. And bonus, it gives you a much more realistic idea of what you actually know.
And hey, the proof is in the pudding. Just look at these results from a real classroom experiment. Students who used spaced practice scored way higher on a test a month later. We're talking a jump from 25% for the crammers to nearly 40% for the spaced practice group. I mean, that is a massive difference. It's a total game changer. But even the absolute best practice method is only half the story. To really, truly master something, you need a guide. You need to know what you're doing right, what you're doing wrong, and exactly how you can get better. And that's where good, effective feedback comes in. So what does good feedback actually look like? Well, it's not just a big red check mark or a letter grade. It has to be specific. It focuses on the work, not on the person. It explains why something isn't quite right. And, this is key, it guides the student towards the correct answer without just handing it to them. It's really a conversation about getting better.
All right, let's get to the final piece of the puzzle. We've talked about how we understand things, how we retain them, and how we practice. But you know what? None of that matters one bit if a student isn't motivated to learn in the first place. This is the human element, and it's everything.
This quote right here, it just cuts right to the heart of the matter. Before any real learning can happen, a student has to feel like they belong, like they're accepted. If they feel like an outsider, or like they're not supposed to be there, their motivation is just going to tank. It's a fundamental human need.
So, what can teachers actually do? There are some really powerful, simple things. They can remind students that it's totally normal to feel like you don't belong sometimes, and that those feelings fade. They can frame tough feedback not as "you're bad at this," but as "I believe you can meet this high standard." And they can help shift the focus away from just getting a good grade to the actual goal of just learning and improving.
So, after all that, what's the big takeaway here? It's really simple. Learning isn't some kind of magic talent that you're either born with or you're not. It's a process. It's a science. And by understanding how it works, we can all become way more effective learners and teachers.
And that really brings us to the final and most important question. It's for you. Now that you've had a peek inside the owner's manual for the human brain, what are you going to do with it? How will these ideas change the way you approach your own learning, or maybe the way you help someone else learn? The science gives us the map. It's up to us to actually follow it.